Hey everybody, this is Larry. This is me going Q3 of the weekly kindness 463 minimum sum after divisible sum deletions. Hit the like button and subscribe on join me in Discord. Let me know what you think about this one. Honestly, I don't know why I struggled a lot with this one. I think I was just not on the right state of head, mind, whatever. I stayed up too late to solve this contest. Maybe a warning to all you. Yeah, but initially I thought that maybe there's some sort of, wow, the sun is coming out, greedy idea, right, of just, you put everything in a stack, you remove stuff, and then I was like, no way, that doesn't make sense. And it honestly just took me a long time to think about it, right? It just took me a long time to think about it. I don't, but the idea is actually not that bad. Let me bring up the drawing board real quick. Yeah, the idea here is that the idea that I was trying to build off is that's my pencil. Okay, the idea here is that so we have an array, right? We have an array. An array. Jeez, Larry, what are you doing? We have an array, right, with numbers, and let's just say there are segments that are what's divisible by 3, right? And of course, let's just look at a random index. Let's say you look at this index, and let's say you wanted that index to be the ending, right? And that means that maybe you could have like maybe this segment you could remove because it's divisible by x, and maybe there's another segment that looks like this, it's divisible by x, or k or whatever, etc., right? And maybe there are more. The first thing to notice is that if you have cases like this, if this is divisible by x or k, that also means that the rest of it is also divisible by x, right? Meaning that another way of saying is that you could break it into multiple pieces, right? That's the first idea. And because of that, you don't ever need to consider this because, well, you can just break it apart into multiple pieces anyway. And if there are more pieces, then it's fine. And the reason why it's fine to do it this way, as you'll see later, is because it gives you flexibility, right? Because now, because you're not trying to minimize the number of pieces, you're just trying to remove as much as possible, right? And so, yeah, and you could it's just that, yeah, you're not forced to take a big chunk because you can take a small chunk and then later maybe decide that you want this chunk instead that's next to it, right? So that's basically the one thing. And then now, and that observation means that because even if there are even if there's like 10 possible things, you only really have to consider the smallest one, right? Because of this principle that all of these are made out of smaller pieces by definition, right? Okay, so we only care about the smallest one, so we just have to keep track of the smallest one, right? We just have to keep track of the smallest one, right? Okay, and then now we know that for each one right index, we only need one left index. And so that means that in a way, and not all of the indexes need a left index to have a a chunk, if you will, that you could remove. But even in the worst case, every index does have one. Then it'll look something like this, right? Maybe this, a little bit of, whatever, right? Sometimes it doesn't go all the way, right? But yeah, and you could keep track of this, you can figure out what the left side is very easily because you could do a prefix sum, right? Or prefix mod sum, if you will, because basically, if this chunk, let's say your mod k is your k is equal to 3, let's just say 10, right? 10 is easier because everyone knows base 10 numbers, right? That means that, let's say if this, another way of thinking about it is that, okay, well, if here the last digit is 5, if you look at the sum and the last digit is 5, then that means that, well, the last time, or whatever this number is minus a previous number to get 10, it's just another multiple of 10, right? That means that here it also was something 5. So it's like some number and then 5, right? Meaning that it could be, say, 15, and this is 65. That's fine, right? That means that, you know, within here it is divisible by 10, right? With you know, sometimes it's harder to visualize with algebraic variables or symbols. You know, you could put in numbers to kind of play with it, right? But yeah, so you can see that if k is equal to 10, we have, you know, you just look at the last digit and mod 10, whatever, right? And you could keep track of the last here. So that part is relatively straightforward to calculate the last index. And then now, once you realize how to set that up, or once you set that up, then again, you just have segments. And this becomes, because you don't care about how many segments you care about, you're just trying to, you know, you have all these segments, you know, maybe it looks like this, and you're trying to get the max sum. And this is actually now, and this is why I feel sad that it took me so long, is that this is now a normal sliding window problem, right? Because you sort by the left endpoint, or, you know, keep track, or in some way you sort by the left endpoint, then now what happens? And you do a sweep line, right? So you have a line, you sweep, you at the beginning of this thing. What does that mean? That means that you take the best of whatever's on the right, because it doesn't matter how many pieces you have or whatever, you just take the best that you already gotten up to that point, and then you merge it with this one, kind of. You take the best, and if we want to merge it with this line, that means that at the end of here, then we update the best. I explained this a couple of times in different videos. I mean, I think the setup for this one is obviously, to me anyway, a little bit trickier. But that's basically the idea, is that you have this sweep line, you want to, you have these segments, you want to take the max sum of the segments, and that's it. Yeah, and the idea, sorry, maybe today I'm just not having the energy to explain. But yeah, another example is that, well, now you sweep, and you're here, right? Actually, I think this is like a very bad example, because I don't have any done ones. But yeah, let's say, different color. Okay. Let's say we have, you know, this on the left side, and then now this is your sweep line, and then now this is your beginning of a thing, right? Here, then now you take whatever the previous that you get, and then you I think of it as a relaxing, is that you relax it here, right? That means that, and there may be more different things. That means that by the time you get to here, then now you update the best, right? For example, if here, everything on the left, the best is 10, this rate is equal to 5, then here, we know that we're at least able to get 15, because whatever we have previously, plus this 5, means that at the end of this event, we get 15, meaning that in future events, we get at least 15. Of course, you pick the best, but when this gets to the next one, then now it's 15 plus whatever this rate is, right? That's kind of the idea. I think the hardest part, I mean, this part of it, honestly, it's on Leetcode. Like, I think I've seen it, I feel like in the past year as a new problem, like, you know, like 3-4 times maybe. So I feel like this is, Leetcode has been doing this in a little bit. So I think the hardest part about this is just transforming whatever word problem that they give you into this. And once you kind of think about it in terms of segment, I think this is pretty okay, pretty doable. Yeah, so we'll go over the code, and it's not even that long. I don't know why. I had a lot of off by ones, but just not having a good day. Yeah, but basically you have to, this is prefix sum. This is the last time we've seen something we put in a thing, right? Next is the prefix sum. Next mod k is that number of mod k. This allows us to get the segment, like this is the 15 to 65 thing that we talked about, right? So if the last digit is 5, we would just want to see the last time the last digit is 5, and then we keep track of it, and then we update the last digit, if you will, if it's mod 10, just to be precise, a little bit more precise anyway. Then you update it to the index, and then you just kind of prefix sum it, right? Yeah. And then the prefix sum is because I guess I skipped this part, but the prefix sum is the weight of the because if you're removing a segment, then you're removing the sum of the indexes or the values living in those indexes, right? So if you have a chunk and you want to remove it, then you want to get the sum of what's inside. That's what you use prefix sum for, and that's basically the idea. And I call it DP because I couldn't come up with a name. I don't know. It's not quite DP. Honestly, it's more of a sweep line. We sweep. I is my sweep line going from 0 to n. I update the best of everything to the left as we talked about, and then for the events that lives here, because this is the start. Maybe I can write like if this isn't last, then start is equal to last, right? And I is the ending, right? So you could think of it this way. Maybe it's a little bit cleaner. I don't know. But yeah, and then in defense, -1 for index reasons because of this and stuff like that. And prefix sum matching. Yeah, in that case, then we update dp sub j plus 1 is yeah. That means because j plus 1 is the thing in the future, we update that best to the rate the best of everything to the left plus the new chunk that we're removing, and then at the end we're maximizing the numbers that we're removing. So that means that that allows us to minimize the numbers that we keep because yeah, it's just the sum minus whatever we remove, right? And that's it. What's the complexity here, right? It's just linear. Maybe it's surprising, but prefix sum is linear time, linear space, right? Event, remember for each index, you can only have one event to the left side. So that means that events have at most linear number of items, right? And yeah. And this loop looks like it could be quadratic or something, but remember that they're only at most linear number of events in total. So that means that if you sum this over all the i's, this is linear. So that's just linear plus linear and not multiplied by linear. So linear plus linear is linear, and you have linear time, linear space. And that's it. That's all I have for this one. Sorry friends, I'm really tired, but that's all I have. Thanks for watching, and you can watch me solve it live during the contest next, even though it took me a long time and a lot of confusion. So yeah. 3 minutes, and that's because I didn't really read and I was confused. But okay, Q3, I need sleep. But okay, focus. Nums k, you can repeatedly choose any number of times any contiguous subarray of nums whose sum is divisible by k and delete it. At least deletion the remaining minimum possible sum after performing. Okay, so this is initially, I was going to say this is bursting bubbles or whatever it's called, bursting balloons. But obviously with 10, n is equal to 10 to the 5th, that's not the case. But that said, there is a greedy portion of this, right? Because of how divisibility works, I think. Am I right? Is it greedy? There's only one unique way, right? Because it has to be a subarray, so you either choose left or the right, but then it all squeezes. I think that's right? So stack. Could be wrong. Maybe I'm wrong. Who knows? Oh, but it. No. This is right. I mean, the idea is right. We just have to figure how to do it. All right, stop dancing. I mean, no, this is fine. Basically, what we want to do is for x in nums, we want to keep track of the index and the running sum, right? So then we have to do a lookup. Yeah, I mean, this is fine, right? So maybe on the stack, we want to put, say, -1, 0. We'll say index prefix sum, kind of, and then you just do like oh, I guess we want to enumerate. I don't know if that makes sense actually, but and the prefix sum is mod k actually. So I don't know if index matters actually. but yeah, because we always want to keep removing. Oh, removing min is interesting. Is it? No, you always want to remove as many as you can. It's always greedy. Because it's mod k, mod properties, right? Okay, yeah, we said that. Okay, I don't think we need the -1 then. We have 0. We want to say scene is equal to. I think set is okay. I don't know if I need a table, but okay. So something like this. Is that the top? That is the top. Plus x, but not quite, right? So basically, we want. Let's say the next number is going to be equal to x plus the top of the stack, right? Mod k. And then if nxt is in scene, then we want to remove stuff, right? Yeah, we've seen that remove nxt, but only if while length of stack is greater than 0 and stack of the top is not equal to next, then pop, and then we just keep popping until then, yeah, right? Maybe something. And then now we just return sum of stack. I think that's maybe right. I don't think there's any weird things. Maybe I'm wrong. Clearly I'm wrong. I mean, I don't remove anything, right? Well, because I forgot to mod. Okay, 1.5, is that right? I want to say that's right. There are no choices. Are there choices? No, there are choices for sure, right? I don't think this is right, actually. Greedy doesn't work, not like this anyway. Because you can have, say, I don't know, k is equal to 2, very simple, odd even, and then you have like 1,1,9,9,9,9,9,9, right? In that case, clearly you would just remove these two and not these two. But in my case, I would, at least the way that I wrote it, I think it actually removes the first one. I mean, we could I'll try to put it in, but I mean, it doesn't even matter, right? And here it'll be, yeah. Oh, well, no, I think I got lucky. I think actually, I missed, right? Someone like this. So that's definitely not. Oh. No, because then we move these two. What? I don't get how my code works. I think it's just luck, but how does either one of these work? We remove 0. That's definitely not. Oh no, we remove it from scene. Oh, we have to remove scene from stuff here too, because then now those things are not possible anymore. I don't think this is right, even though I cannot get a wrong answer from whatever. Because if nothing else, I need to remove the progress. That's just wrong, right? So 1 1 1 1 1 do 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 do. Well, we don't add anything to it, so that's just wrong. Add this thing, right? I mean, that was just way wrong in either case. But I don't know why this is wrong. I mean, this is wrong, but okay, how else am I going to think about it? No, this is wrong. How much time do I have left? 1:12. I mean, even if I get my implementation is bad, but even if I had gotten it right, it is wrong. By definition, this is not seen, and also this is just next. I guess this kind of evens it out a bit. Oh well. Well, no, because then now this is an else, I think, because we do remove this current number. Okay. But why is this right? Oh no, this is not right. Okay. So that is also weird because I didn't expect it to be right, like, or I didn't expect it to be wrong the other way. Because going lower means that it is just I don't know, removing some funky numbers. But we can maybe just rewrite this, right? Right. Alright, let's just print out the states. I don't, I mean, this isn't right, but I'm trying to see what I can get insight from here, right? So here you have 0, you have 1, 0, 1, okay. You see a 1, so you remove, and then, okay, whatever. I guess that's a trivial case. Here we have 0. Well, we moved to 0, so that's why it gets removed. And then 1, and then the 4. Yeah, so then you have 2 as the mod, and 1. This should remove all these. Oh, Oh, I see. I'm just silly. Oh well, I'm silly in that I got lucky in that I cannot just sum stack because stack don't actually hold the number. Stack holds the number with the mod or whatever. But also the last number is the prefix sum, so it doesn't even make sense. Like the top of the stack is more accurate. So I'm like wrong in like 3 different places that happens to be whatever. And this isn't even the mod, right? This is the whatever number. So yeah, so 5 mod 3 is 2, so that's why this is 2. But yeah, and that's why these enter are 1, because I just have mod 2 and I got lucky and showed the wrong thing. Okay, but how? I have to think a little bit more. This is not the right way to do it, even if I implement it correctly, which is just keeping track of more states, or not states, just more variables. The original number as part of the stack, and then that will help. And then just sum up the second number. But that's not what I want to do, because that doesn't help me get min. All right. So how would I do it? I mean, okay. So by definition, if a number by itself, I mean, this is the only case that I can think of. And would you do it by greedy? Is there an exchange argument? Because this is a problem in which leaving it to do later does make sense. Right? It's not greedy in that you can't just scan from left to right. Can I use other tricks? Like nums only go up to 1,000,000. Does that help? What does it mean to be deleted? And it's contiguous. Okay, just want to make sure, because otherwise this is dumber. Or at least I'm dumber for not reading it. I thought initially I could do it greedy, but I really am wrong by this case. Doesn't even make sense. and then you have like random things where you have two pieces, right? Like for example, you can if you try to like hold this one for this, then what happens if there's another one, right? Then now they match, right? And then you have like a weird, I don't know, is it 10 to the 5th? Huh? Is it greedy? So what happens if you have two subs? Yeah, how do you like differentiate between like this one and this one even? If you just have k is equal to 2. Is it just dp? I guess it is just dp. It is just dp in that you create segments. How many segments can you have? The longest contiguous segment, so then for each right endpoint, you're at most one left endpoint, and then you do a dp on that. Okay, that makes sense actually. That is a hard problem. How did 2,000 people solve that in 1 minute? Well, okay, you know why. But still, okay. Is that really? No, that makes sense. Okay, so we just create the segments. Not quite, not the same though. So maybe prefix sum is equal to something like this, right? And then we want the first index. No, do we want the first index? No, we want the last index because it doesn't make sense to do greedy on the segments because it can be divided up anyway, so you could greedy in those terms. Okay, okay. So then now you want the last seen prefix. Okay, maybe that makes sense. Okay. Okay, yeah. Okay. Yeah. Right, so okay, so okay. And then maybe like a previous times n, yeah, fine, right? Yeah, okay. And then now, so then if nxt is in last, then previous of I is equal to last. This is going to store the index, and then at the way that's is equal to I. So something like this, right? And then now this gives you all these segments, and then you do the DP thing, and maybe we need a better mapping here, but this is a hard problem though. 2,000 people is ridiculous. Or maybe there's an easier way though, so maybe I'm wrong. So, but is it DP or is it the greedy version? No, I mean maybe it's the greedy version. I mean it is greedy, but it's not really DP, but it's just storing down the best possible values at that point, right? Yeah, just updates, right? So then now, maybe instead of previous, what I want events. Maybe I lied on this one, right? So then now we want then start a pen. Because we want to minimize, so we could say we want to maximize the removal. So we want to say it is from last sub next, that's last index, and I or I plus 1, I don't know, and then that's gonna have a value, but we could just get that from the prefix sum, so it's not interesting yet. Or we could get that later, right? Yeah. All right, I mean, I think it doesn't matter. None of this matters. It's just off by 1 or not. You just have to be consistent now. Okay. So then now we do events.sort. No. I like writing it in a different way nowadays. I mean, I think I usually do it this way, but actually I just want to go forward. So I want to do it this way. Append I, right? And then now events would already be sorted. So then now for, well, it doesn't even matter. We'll just go for I to, it's a little bit cleaner. Okay, so then now best so far is our DP. We say it is 0 for removal. And then now at I, we want to, there's 2 events. I'm too rusty at this. This should know this, but okay, but I should be able to solve this anyway. Okay, so then now at I, yeah, that's why I had a what I call DP, but it's actually no, just like DP. Okay, so how do I want to say this? Why am I? Whatever. Just call it DP. It's not DP, but it's not DP, but it's fine. Otherwise, I'm spending too long on spending time. Okay, so then now best is equal to 0. So then we want to update for X or J in event sub I. We want to update DP of either J or J plus 1. J plus 1. And then we do the, okay, I think that's right. Is equal to max of itself, fine, and now let's use f max. I worry about performance on this one. Okay, so it's either that or it's going to be best plus whatever the substring is from I to J. So then it's just prefix of I plus 1 minus prefix of J, right? Okay. But before that, we want to update. But that means that this has n plus 1 states. That's why. And we can probably just do it this way, even though that's a little bit awkward. So best is you go to the best we've seen so far, or DP sub I. I think that's right. And then that's the max. So we want to return sum of nums minus best, something like that. Oh, did I not define previous? I don't think I need it, right? I changed my mind on how I implemented it. This is, did I just do it the other way? This is best removal, but I print DP, print best, DP, it is 0, 0, 0, and 1. That's not right. Prefix sum is not right. No, because it is, well, it's J and 2I. That's why it would never match. Okay. So now it's 2, 13, and big number is still not good. Why am I so off here? This is the last time that not happened. Prefix. Oh, it's not prefix. This is not the prefix sum. That's the prefix sum mod k, but how do I? Okay. What is going on? Okay, maybe that's a little bit better for the prefix sum. All right, I mean, maybe too good. All right. Am I off by 1? what am I saying here? All right, let's look at my events. What my events? Okay, window too small. All right. So you have going from 0 to 2. That's, oh yeah, right. Where do I have the +1? Where do I have the +1? No, I didn't go +1. Oh, because 0 is, and we go from 0 to 2, which is wrong. For sure, it should be, well, no, I have a +1 somewhere, right? Is that why? Yeah, j +1. But I already have it from 0 to 2. I is 2, but the prefix sum of 2. Alright, well, let's also print the prefix sum. Maybe I'm off by 1 somewhere. Very awkward, actually. 0, 1, 2, 3. No, that part is right for prefix sum. Let's print last. I'm like off by 1 somewhere. I'm just not careful. Okay. So 1 is going to be 0. 0 is going to be 1. Oh, that's not true. We 1, 0 to -1 or something. Yeah, something like that. But I don't know if it gives me an out of bounds issue. Because last of. Because we want it from the prefix. I think that's why. So then now events are from -1 to 1, which is kind of right, and that it should be the key +1 because of the prefix sum. It's very awkward actually. How do I want to handle it? I mean, something like this, but it's not quite. Okay, maybe I could just do this. Maybe does that make sense? No. No, it doesn't make sense here. No, but you want to start at -1, but well, no. If anything, it is. I mean, it's just I -1 because we map the events. Is it? Because it's 0. So we're at 0, we go to -1. So at 1, we're going to 2. Okay, fine. But then now we want to go from 1 to, so 0 going to 3, when it should be 1 going to 3. So that means that this is +1. That is such a mess. You're a mess. Okay, but am I a mess that's correct? No. That's the more important part. Okay. I just print I to j. 0 to 1 is right, and 1 to 2 is right. So what is dp? dp is 0, 0, 1, 1. That sum is not right. I'm debugging silly things. I am not a smart boy today. I mean, maybe that's clear. Okay, yeah, that's not the prefix sum. And I knew that, but I thought there was a -1, so maybe I. Okay, let's see. Alright, 1511. Okay, so I think this is good. It's very possible that I have a typo, to be frank, or something like that. But it's good for these cases and even these two, so I think that's maybe fine. Let's actually print dp real quick. I just actually want to double check. Yeah, the max is, this is the max, this is the max, and then best is just 10,000 or whatever this is. As a result, do I miss one of these? I think maybe I do, but I go through all of these, which is all dp. Maybe that's fine. Do I go out of bounds? J. I goes to n. I goes to n. That's, well, I mean, No, I mean this would have found it, I think, because it would be these two. So if we're off by one, it would have caught it. Okay, let's YOLO submit. If not, then I'm just a silly boy, which is happens. Okay. Whew, that is a hard one. I don't know how 2,000 people got in it, or maybe, like I said, maybe they did it in a smarter way than I did. We have 50. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.